Hey everyone, I'm Ned Bellavance, and thank you for joining my talk today about using Ansible and Terraform together. For those who don't know me, my name is Ned Bellavance. You can find me at nedinthecloud.com. I'm a HashiCorp ambassador and just general enjoyer of IaC. Now let's get into the actual topic at hand, talking a little bit about Terraform and Ansible. So what are we going to cover in this talk? We're going to start with an exploration of why Terraform and why Ansible, and then how the two actually work really well together. We're not going to go deep into either of those because I'm going to assume you already have some familiarity with Terraform and Ansible, but we'll cover some high-level points that I think are germane to when you're picking one versus the other for a particular task. Then we're going to talk about some integration strategies. How do you integrate the two tools together, passing information back and forth? Then we'll jump over to a real world example I have set up on a GitHub repository, and I'll make sure to show you what that link looks like and make sure it gets shared out later in case you want to take it for your own test drive. And then talk a little bit about the best practices and pitfalls when you are integrating these two tools. So some things to keep in mind. Now, first, let's talk about Terraform. Why Terraform? And when I say Terraform, this also goes for OpenTofu. So we can use those interchangeably when we're talking about when you would want to implement either of those tools. What does Terraform excel at? It excels at the provisioning of infrastructure and managing its lifecycle. And when I say infrastructure, that can be a little nebulous, but we'll come back to that a little bit later. A key feature of Terraform is the fact that it uses a declarative language to describe the environment or infrastructure that you want to have set up. So rather than telling Terraform how to do something, you tell it what you want to exist, and then Terraform makes it so through its own internal model and also leveraging providers. Terraform is idempotent by nature, by which I mean if you apply an unchanged configuration to existing infrastructure, no changes will be made to that infrastructure. Terraform does this by using a state file to represent the current state of infrastructure and then comparing that to what's in your configuration. If there's no differences, then no action or changes will be taken. And that's baked into Terraform at its core. The way that it determines what changes need to be made is by building a graph. So it figures out, here's all the resources, data sources, and other objects in your configuration. I'm going to build out a graph, a tree that says, here are the things that need to be created or destroyed, the actions that need to be taken, and then walk the graph. Here are the actions I need to take, and also the order in which I need to take them, which allows Terraform to determine dependencies. Those can be implicit dependencies that are implied by the configuration or explicit dependencies that you specify inside the configuration. Lastly, and most important, Terraform is API focused. The core assumption of Terraform is that it's going to interact with infrastructure using an API, using a provider. Provider plugins in Terraform provide that interaction or interpretation layer between what Terraform understands, the language and concepts inside of Terraform, and the actual resources that you want to manage in your target service of choice. That could be a public cloud, it could be a Kubernetes cluster, it could be VMware on-prem. Really, you can manage any of those things as long as there's an API and a provider. So that's how Terraform gets work done. It assumes it can talk to an API through a provider. Now, why Ansible? How is Ansible different than Terraform? Ansible is generally used in two different realms. One is heavily in configuration management. And how does configuration differ from infrastructure? Again, I'm going to expand on that in a moment. But generally speaking, configuration management has to do with configuring the internals of a resource once it's been provisioned. That could be a virtual machine, but it could also be a network device or really anything else that Ansible can connect and run commands against. It's also used for application deployment. Once I have a virtual machine available to me, maybe I want to connect into that virtual machine and install an application, and I want to update that application over time. Ansible can do that. While portions of Ansible's language are declarative in nature, it's ultimately procedural in the order in which it executes instructions. So when you create a playbook with plays and tasks in it, those tasks are executed in sequential order inside of a play. Now, there are ways you can get around that. There's like an async task that you can implement, but generally speaking, it's going to be procedural and done in a serial way, which is a little bit different than the way that Terraform is approaching things. Also, idempotency is not guaranteed by Ansible itself. It's something that has to be written into the modules that you're consuming within Ansible. So Ansible itself doesn't guarantee that idempotency is going to be there. It's reliant on the modules to correctly interpret what they find and determine if changes are required if nothing has changed about your play. Ansible also requires you to be more explicit about your dependencies, and that explicitness is usually through the order in which tasks are laid out inside a play. You say, I have to do this task first. I have to install Nginx before I try to restart or start Nginx and load a website, or I need to install these dependencies before I deploy a database on this server. You have to be explicit about those dependencies. It doesn't build a graph and determine that on its own. Another big difference is that Ansible is agentless. It doesn't run on the devices that it's configuring. It runs from a control node. Now, that's actually very similar to Terraform. Both of them run from some sort of control node or worker node that goes out and provisions infrastructure and configures things. The big difference is that Ansible is connecting directly in through SSH to perform operations on that device or on that virtual machine, whereas Terraform is relying on an API and a provider to do that. In scenarios where your virtual machine or your device is behind a firewall, Ansible either needs to be moved inside of that realm to talk to that device directly, or you need to punch a hole through your firewall. Whereas Terraform, if it can talk to the API endpoint for the thing it needs to configure, that's all it needs. Now, sometimes that API endpoint does live inside your firewall and you need to move Terraform inside it, but it is a different way of connecting and configuring things, which gets to our core thing, infrastructure versus configuration. Where do you draw the line between this is infrastructure that I'm deploying and then this is stuff I need to configure? And it's fuzzy. It's a really fuzzy border. So fuzzy that here's a cat. So we can kind of just look at the cat while I try to describe this. This is my cat, Leo. He always wears a bow tie because he's a very, very fancy gentleman. And as a fancy gentleman, he knows that the boundary between infrastructure and configuration can be pretty fuzzy. The way I tend to think about it when it comes to Ansible and Terraform is if it has an API that Terraform can interact with through a provider, then it's infrastructure, and it should be treated as such. Infrastructure is generally going to be pretty immutable, and it's going to be idempotent in nature. If it's fuzzier, if it doesn't have an API, if it needs a shell script to run, though in those scenarios, now we're talking more about configuration management. And that's where Ansible comes in and handles the configuration management side of things. The good news is, these two things are better together. Terraform is great at creating infrastructure, and Ansible is great at configuring the underlying infrastructure once it's been provisioned. So I like to put them together. And the general workflow that you'll find most of the time is Terraform takes care of creating the infrastructure, and then it passes some information to Ansible, and then Ansible configures that infrastructure, whether that's virtual machines or network devices or who knows what else. Because Ansible has a lot of modules and can do a lot of things. If it has an API and it can be configured through a provider, I would keep that with Terraform. If it's fuzzier and required scripts to be run and more customized workflows, then I'm going to hand that over to Ansible and use some modules or collections in Ansible to do that management. So how do you integrate? How do you put these two tools together once you've determined that you want to use both of them? Well, I think it's important to kind of review, how does information flow into both of these tools, and how does information leave both of these tools? Because that will show you the integration points between the two. So how does information enter Terraform, a Terraform configuration? There's three different ways to sort of get information into Terraform. There's input variables. These are variables that you define inside your configuration, and then you provide values to those input variables at runtime. Then there's data sources. Data sources are a resource that's read-only for Terraform, but it can reach out to whatever provider it is and get information about a resource that already exists on that provider. That could be an existing security group in AWS. That could be a resource group in Azure. It could be an existing cluster in Kubernetes. There's all kinds of data sources out there, but it's a way for Terraform to pull information in. And then the last one is functions. There are a few functions in Terraform that let you pull information in from a file. So there is a file function that lets you read in the contents of a file from a particular path. Now, given those three input types, what form do the inputs usually take? If you're dealing with input variables, those inputs are generally going to be a variable file, or you're passing it through environment variables. If you're using data sources, you can connect Terraform to other Terraform configurations by using the remote state data source. Some people don't like that, and I think there's a healthy argument to be had there, but regardless, that is an option. Another option is to store your data that Terraform needs in a configuration store of some kind, something that holds like key value pairs. Think AWS's SSM parameter store, or also Azure's app config. Either of those would be good examples of somewhere I can store my configuration and have Terraform, using a data source, pull it in and use that info. And then the third one is if you're using functions to pull in file information, Terraform has native functions to look at and inspect JSON, YAML, and CSV data and parse it using native Terraform syntax and functions. So if you wanted to pass information, say, from Ansible to Terraform, and your inventory files are in YAML, then Terraform can read your inventory files because it can interpret that YAML. It's interesting possible workflow there. Now, how does information leave Terraform? There's a few different ways information can be extracted from Terraform. One is output values. You define output values inside your configuration, and when a successful apply happens, Terraform will print those output values to the terminal. You can also retrieve those output values anytime by running Terraform output, and that's something that we'll see in the demonstration. You can also get information from resources that have been provisioned by Terraform. So if you have proper permissions, you can just go out to the provider where you deployed those resources and read information directly from them. You don't have to rely on Terraform to give you that info. And lastly, you could read Terraform state data directly and interpret what's in that state data and use that information. So that can take the form of reading state data directly. It could take the form of running CLI commands to get information from Terraform, like Terraform output. It could be that Terraform puts information in a configuration store, like SSM parameter store, for something else to read. It could write data out to a configuration file, or it could be relying on something implementing remote state. Now, what about the Ansible side of things? How does Ansible get information into its configuration, the thing it's going to deploy? Generally, it's going to be through inventory or variables. So inventory defines the hosts that you're trying to manage with Ansible, and variables define settings you want to use with those hosts. Where does that information come from? You could get the information for inventory from one or more inventory files that are located near your Ansible configuration. For variables, you can pass information through environment variables or CLI arguments. Ansible also supports the use of dynamic inventory, which allows Ansible to essentially run a script or a plugin to discover information about hosts based off of properties of those hosts. A good example of dynamic inventory would be the ability for Ansible to query for Azure virtual machines that exist in a particular resource group and subscription by tag. That could tell it, okay, so I have these servers, they're tagged as web servers in this resource group, so I'm going to apply this play to those particular servers. And it could do that dynamically. It doesn't need those servers to be hard-coded into a file. And then lastly, you can add additional variable settings through group and host variables. So that's how information is going to arrive into Ansible. How does information leave Ansible? That one, a few less options maybe. Because it's using the inventory file, you could also read that inventory file and find out information about it. Ansible can create temporary files that something else could read. The log data that's sent to standard out, you can also send that to a log file and have something interpret those log files. And modules are also able to emit outputs and may produce outputs of some kind, which you could use to store information in one of those configuration stores that I talked about earlier. There is a module that will write to AWS SSM parameter store. You could incorporate that as a play in one of your playbooks as a task and have it write information out once it's done doing a bunch of configuration work. So those are some of the integration points between integration points for Terraform and Ansible. Binding them together, well, that's going to depend on your workflow, but there are a few approaches that I want to go over. One is for Terraform to use the local exec provisioner. Now, if you're not familiar with this, the local exec provisioner allows Terraform to run an arbitrary script locally where Terraform is executing from. HashiCorp does not like people to use provisioners. They're around because they do serve a function occasionally, but if you can find any other way to do that integration, that is preferred, and that's because provisioners don't respect the same dependency graph and immutability, or not immutability, but idempotence that Terraform has otherwise in all of its other actions. They step outside of that model, and for that reason, they're generally not a great idea, but it is possible. Another common way is to run automation scripts that automate the Terraform run and the Ansible run and provide some glue code between the two on your local machine, if that's where you're running both of them from. You can then take that same sort of idea and you can put that into CI/CD pipelines where you can add more discrete steps. You can add stages to your pipeline and break things up however you want and abstract some of the stuff that you would normally put in an automation script. And that's what we're going to see when we look at the demonstration. And then lastly, there are platform integrations. And one that I recently covered was Spacelift has a tight integration between Terraform and Ansible, the ability to pass the outputs and values from Terraform to Ansible without you having to write any glue code. I don't think they're the only ones doing this. It's just something that I recently saw, and that will save you some trouble in terms of having to write that integration yourself. It already exists on some of the infrastructure automation platforms out there. So those are some of the options. Now it's fun time. We're going to get into a demo. So let me pull up the GitHub repository that has my code. Where is that? There we go. Okay. So here is the code that we're going to be stepping through. Let me bump this up one more just so it's nice and big so you can see what's on the screen. This is a public repository, so you can go to my GitHub. It's Ned1313, and the repository is called Terraform Ansible Example. Should be pretty easy to find. And what I'm going to do is first I'm going to kick off the GitHub action that orchestrates the deployment. And because it might take a few minutes, we can look through the code while that action is running and then come back to the action. So what I'm going to do is I'm going to go into the Terraform directory where my configuration is, and I'm going to update the value for one of the input variables. Down in here, my VM count is set to 1. I'm going to change the default to 2. There we go. And then commit those changes to the main branch. I know I shouldn't be committing to main, but I'm going to because it's faster. Okay, those changes have been committed. And if I go to GitHub Actions, it's kicked off an action based off of that update I made. So we'll let that run and we'll come back and kind of look at the code that is being deployed through this GitHub action. So my code is organized into the Terraform configuration, which lives in the Terraform directory, and then the Ansible configuration that lives in the Ansible directory. I didn't get real funky with this, right? Let's take a look at the Terraform configuration first. And I'll jump into the main.tf so you can see what resources are being deployed. So I am creating a key pair for the virtual machines that are being deployed by this configuration, that key pair needs to be shared with Ansible so it can successfully connect via SSH to those machines. So it's going to need to know the private key for this machine that's being spun up, and it's going to need to know the public IP address of the machine and the username that was configured for the machine. We'll see how that information gets passed in a couple moments. Standard, create a resource group, subnet, network interface, and give it a public IP address. So that's the public IP address right there. Scroll down a little bit more. Here's the Linux virtual machine that's being spun up. And it is using the count meta argument. So I'm creating 2 of these because I updated my default value to 2. So it's going to create 2 virtual machines. Under admin username, I'm using a variable var.admin username to set the username. I'm going to need to expose that to Ansible. I'm also configuring the SSH key that's being used by the machine. And then if we scroll down a little bit more, I'm creating a security group that allows traffic on port 22 and on port 80. So this allows HTTP traffic and SSH traffic. Again, that SSH traffic is going to be how Ansible connects in and installs Nginx on this machine. Now, in a more secure scenario, I might not expose that through the public network, and I might be running this through a worker node that's inside the same VNet or peered to another VNet from another VNet to be able to connect in directly to over SSH to this machine and do the provisioning, as opposed to allowing traffic on port 22 from anywhere. But for expediency and simplicity, I did it this way. So just kind of like bear that in mind. Now, if we look at the outputs that are defined here for Terraform, this is how I'm passing information to Ansible. I have an output that is my private key. So that is the private key Ansible needs to use to connect to SSH. I have the public IP addresses for any virtual machines that are provisioned. It's going to be 2 in this case. And then I also have the username that was used for that virtual machine. That information is being passed to Ansible so it can do what it needs to do. What does it need to do? Well, let's look in the Ansible directory. In the playbook that is being passed to Ansible is this one, and it's looking for any hosts that are grouped under web, and it's installing the role, or it's using the role Nginx for the tasks. In my Nginx role, I have a default in here that sets the Nginx port to 80, and then under tasks, I have a task that simply updates apt, installs Nginx, and then make sure that Nginx is started. So this is pretty simple what Ansible is doing. Now let's jump over to the GitHub Actions and take a look at the code that is gluing these 2 things together. So if I expand my workflows here and go into the deploy workflow, this is where the magic happens. Every time there's a commit on main, this action runs. But it only runs if there's a change in the Terraform or Ansible directories. So if I update the README or something like that, it's not going to run. This only runs when an update has been made with Terraform or Ansible. And that's probably when I do want to run this. Scrolling down a bit, I'm going to kind of jump over some of the code and get down to the Terraform apply. So Terraform apply is set to auto approve right now, but that's where Terraform does its work. If there's no changes, then there'll be no changes. Then there's no harm in running Terraform apply because it's idempotent. Now I need to construct the information that Ansible is going to use. Remember, it needs the SSH keys, the public IP addresses, and the username. So first, we're going to create the file ID_RSA, and we're going to do that by running a Terraform command. Terraform, and since this is running from the working directory Ansible, I need to tell it where the working directory is that has my Terraform config. So Terraform is in the Terraform directory. I'm running the command output, and the output I want is the private key. The raw flag just ensures that it doesn't put any quotes around the private key. It just keeps it straight what that private key is. And I'm going to dump that information to the ID_RSA file and then schmod it to 600 so SSH will use it. For username, I'm doing the same thing again. I'm running the Terraform output command, and I'm asking for just the VM user name this time. Then I'm going to create the inventory file that Ansible is going to use. So start by echoing out web to inventory.ini. That's the web group of the servers that I want to configure. And then I have this sort of glue code here that first gets the public IP addresses from the public IP address output that's defined in Terraform. Once that's done, it's going to make sure that no errors happened when it tried to grab that information. Because if there's no output, then there's nothing for it to do. It can't move any farther. Assuming that there is output, it checks to see if the output is an array of public IPs, which it should be. And assuming that it is an array, which it's using JQ to do that, I should mention the output here is going to be in JSON form. That's what the JSON flag does. So I can interpret it using JQ instead of just getting plain text out of the output command. So I'm going to use JQ to parse what's in the public IPs. And for each IP it finds in that array, I'm going to echo out a new line to the inventory file that includes the public IP address, the Ansible username, the path to the private key that it needs to use, and some arguments to let it know, don't worry about it not being in the known hosts file because it's never going to be in the known hosts file. This is an ephemeral worker that's going to go away when it's done. With that all set up, I now have my inventory.ini file, and now I can install Python, install Ansible, and run the Ansible playbook down at the bottom, passing it this inventory file that I just created. So that is what this deploy.yaml workflow is doing. And assuming that everything went well, I can go over to actions and yep, it finished. It took 3 minutes. So that's pretty good timing. All right, so my deploy action finished, and we can see all the checks in here look good. It successfully deployed the 2 virtual machines using Terraform apply. And if I scroll down to the bottom of the output from the Terraform apply, we'll get there eventually. Down there is the private key, the public IP addresses, and the username. And since it prints the output to the terminal, that's also in the logs of the GitHub action. Now, there are other ways to protect the private key if this is going to be an issue. But again, for expediency and time, I just did it this way. Then it created the Ansible keys. It installed Ansible and ran the Ansible playbook. And if I go to one of these public IP addresses, I should get the Nginx starter page. Boom. All right. So we've successfully installed Nginx on 2 machines. That playbook could be anything. This is just a easier representation of what you could do. So that's what's in my demo. A few key considerations to think about if you're going to be melding these 2 things together. The first thing is to maintain idempotence. That's very easy on the Terraform side since that's kind of built into things. But you do want to be careful and thoughtful about the modules and playbooks that you consume on the Ansible side to make sure that it is truly idempotent. If nothing changes about the Ansible configuration and what it's managing, it shouldn't make any changes to those managed hosts. Loose coupling is better. What do I mean by that? The coupling between Terraform and Ansible may change over time. You may change the way you want to expose values. So you don't want to necessarily tightly couple the 2 together. This one was relatively tightly coupled. I'm reliant on the outputs that were created by my Terraform configuration with their precise names and data structures for Ansible or my glue script to extract that information into files and then have Ansible pick up on that. How could I less tightly couple the 2? Well, one option would be to use dynamic inventory. So instead, I could have a dynamic inventory plugin. Once Terraform has done its work, go and find the virtual machines in the resource group that was created, and then populate my inventory based off of tags that were assigned to those VMs. And I can house that information in a common configuration file that both Terraform and Ansible are using, the resource group name, let's say. So that would create a looser coupling. If I want to use a different Terraform configuration to manage those virtual machines, or I want to scrap Terraform altogether and start using Pulumi, I don't know. As long as those virtual machines continue to exist in that resource group, Ansible does not care. And that's what I mean by loose coupling. You may want to also incorporate some alternative workflows, by which I mean there may be situations where you only want to run Ansible or you only want to run Terraform. If they're both idempotent, it doesn't matter if you run both, but from a time perspective, it may be faster and more efficient, especially when you have a lot of hosts you're managing, to skip Ansible if there's no changes related to Ansible. So you may want to build that into the logic of your pipelines. And then lastly, when you're building these pipelines and these glue scripts and these integrations, it's best to standardize on them as an organization or as a team so that you can create reusable automation scripts and integrations that can work across whatever department or group or team needs those things. So a few things to consider. That is going to do it for me. I hope that this has been informative and interesting for you. If you want to reach out to me, again, my name is Ned Bellavance. You can find me at my website, nedinthecloud.com, or I'm pretty active on LinkedIn.